Hi, everyone. Thanks again for coming. I'm Laurel Sindwall, the PhD candidate in Diana Tombach's Forest Ecology Lab at CU Denver. I am co-organizing this webinar with Tio Rautu, a master's student in Danielle Ulrich's lab at Montana State University, and Vlad Kovalenko, a master's student in Diana Six's lab at University of Montana. Welcome to the first webinar installment of 2023. If you've missed any of our previous installments, you can find recordings of the talks on our YouTube channel. The link for that and for our website is in the chat there. It's my pleasure to introduce today's speaker, Enzo Martelli, who is a PhD student in Forestry and Conservation Sciences in the Nelson Restoration Ecology Lab at the University of Montana. He received his MS in Forestry at the University of Montana in 2022 in the Nelson Restoration Ecology Lab. Congratulations, by the way. And his BS in Resource Conservation, working with the Pouchard Biological Invasions Ecology Lab at the Universidad de Concepcion in 2018. Enzo has worked on a variety of conservation and restoration projects, including a Nothofagus species IUCN Red List assessment, lodgepole pine invasion in alpine Araucaria forests with the Corporación Nacional Forestal in Chile, post-road decommissioning, vegetation recovery in Montana with the Collaborative Forest Landscape Restoration Program, and most recently, restoring whitebark pine ecosystems with the U.S. Forest Service Fire Lab. Today, Enzo is here to talk about his research on the ecological effects of prescribed burning and mechanical cutting for whitebark pine restoration, 15 years after treatment. His findings may surprise you and are certain to be impactful for whitebark pine ecosystem restoration into the future. If you have any questions following Enzo's talk, we encourage you to virtually raise your hand so that we can enable you to unmute yourself and start a dialogue. If you are unable to do so, you may put your questions in the chat and I will read them. With that, I'll turn it over to Enzo. Thank you.
All right, thanks for the introduction. Can you hear me well? Yes, all right, perfect.
Loud and clear.
All right, so thanks all for joining us today. During the next minutes, I will present you the main results of my master's project on whitebark pine restoration that we call Ecological Effects of Prescribed Burning and Mechanical Cutting for Restoration of Whitebark Pine 50 years after treatment. So the results that I share today will provide relevant insight on two main topics. The first one of them is the ecological response of whitebark pine to silvicultural practice on three main variables. The first one is going to be mature trees mortality. The second is shifts in canopy composition with competing conifers. And the third one is whether these practices can enhance natural regeneration or not. And the second main topic is an assessment on the efficacy of the study design, in which I'm going to show the main limitations of it for ecological inference, and also the main implications for natural resource management. So I need to share my screen now. Give me just 1 second. This will stop. All right, can you see my screen? Can anybody see my screen? Yes?
Yeah, sorry.
Okay, that's totally fine.
Looks great. Thank you.
All right, I totally forgot to set it up. Oh, I need to go to our screen. Give me a second. All right, so let's start. Well, over the last 30 years, the field of ecological restoration has experienced a rapid growth in the number and also in the extension of different projects implemented, as well as the research. And in response to this rising interest, there's also been an increase in the needs for reliable and also generalizable information on the efficacy and the effects of different management practices, most importantly, to extrapolate this to global restoration initiatives. One of those important global restoration initiatives are the United Nations Decade for Ecosystem Restoration. However, despite a widespread agreement that long-term replicated bucket designs are required to assess treatment efficacy and effects, there is still limited information and application of these designs. And for that same reason, we do not know what are the potential challenges and limitations of it on different types of ecosystems and setups. So for forest restoration, It's particularly important to understand how changing environmental conditions and ecological disturbances can affect ecosystem response to forest management practices. And specifically, there is a need to understand how stochastic events, as wildfire events, can impact ecosystem response, and also the capacity of the designs that we implement to detect these changes. Outside of a few forest types, there is relatively little understanding on the ecological effects of management practice for restorative purposes, and information is especially lacking in forest type without commercial value, such as subalpine forests. And on the other hand, in dry, low to mid elevation coniferous forests, these practices, specifically thinning and burning treatments, has been broadly implemented to reduce fire hazard and also to increment the resistance to fire severity. And for that same end, there is a growing and also big body of literature in focus on the efficacy and effects of these treatments. However, we do need more attention on these ecosystem types that have not been studied as profusely, like the subalpine forest. And in this part is where whitebark pine communities come into the picture. Specifically, as most of us may be familiar with, whitebark pine is a species of high conservation need with limited understanding of its response to management intervention, which makes it an ideal candidate for assessing its response to different types of management interventions. This subalpine tree is considered a foundational species in high elevation forest communities for multiple aspects and due to its importance on the structure, composition, and function of these ecosystems. And like many other tree species, its populations have undergone a dramatic decline in recent decades all around the globe. The primary causes of mortality include some of the main topics that has been described in this webinar series, as well in previous conferences that focus on the native insect mountain pine beetle and also in the invasive pathogen Cronantium rubicum. Furthermore, there is concern that extensive and successful fire exclusion policies over the last centuries may have contributed to population decline by reducing the area burned under natural conditions on whitebark pine forests, and also allowing shifts in composition to shade-tolerant competing conifers, specifically subalpine fir and Engelmann spruce. And this affect the Clark's nutcracker catching habits, and by consequence affecting the dispersal behavior of whitebark pine. Concerns over these threats over whitebark pine forests have led to its listing under both the US and Canadian Endangered Species Acts, and also its listing under the YUCN Red List of Species, and prompted management across different types of organization, creating strategies for its conservation, such as the range-wide restoration strategy for whitebark pine, which is the one that I use as a model for the assessment on the ecological response to different types of treatment. The range-wide strategy for whitebark pine calls specifically for the removal of shade-tolerant competing species, specifically to improve stand health, create fielding conditions for prescribed burning, release whitebark pine for competitors, promote natural regeneration, and also promote diverse age class structure. Although there is some evidence that mechanical cuttings on competing conifers may increase rates of radial rows of Pinus albicollis, it also mitigates damage of mountain pine beetle and blister rust. There is also non-conclusive and negative responses to thinning that have been observed, like the results that Colin Mayherd reported in 2018 after a couple of years of mechanical removal. In addition to mechanical harvest, the range-wide restoration strategy also calls for prescribed burning to emulate wildfire regimes on whitebark pine communities, release whitebark pine from competitor species, recover spatial heterogeneity, promote natural regeneration, and promote diverse age class structure. However, adding fire back to the landscape can also be restorative in some forest type, but fire may also increase mortality in some mature whitebark pine stems. Actually, some modeling approaches, as the ones published by Sharon Hood and her collaborators, have shown that fire can be as much a threat as benefit, and there is some field evidence that trees that experience any amount of burn damage to the bole may have high rates of mortality, as the results shared by Karen Nelson and also Megan Cavill a few years ago in one of the foundation conferences. So, developing effective monitoring programs to understand treatment effects is challenging in general, but especially more for species that exhibit both high spatial variability and complex regeneration dynamics. And we mostly are familiar with the fact that both of these are true for whitebark pine. And in order to make reasonable inference from studies of effects of pathogens, it is critical to assess the efficacy of the monitoring designs, and for that reason also to adaptively change it when necessary. This last point, which is maximizing the efficiencies of monitoring designs, is especially important given that lab managers must balance generating reliable information for decision-making with two main issues. One is limited funding, and the other one is limited personnel. So, with all this in perspective, we currently know that few mechanical cuttings and even fewer prescribed birds have been monitored for their ecological effects on whitebark pine communities, and that the available information shows contrasting results and potential study design limitations, suggesting that monitoring is a priority need. Additionally, there is a need for monitoring efforts to use designs that can separate treatment impact for underlying spatial and temporal availability, which can be high in forest types as the ones presented in subalpine forests. So in this presentation, I'll show you the assessment of the only long-term replicated package design that I'm aware of on the efficacy of ecological effects of mechanical cutting and prescribed burning in whitebark pine forests, as well as to explore the effectiveness of the sampling design. For that end, we defined 3 types of research questions. The first one is focused on the ecological response to treatment, where we ask ourselves, what is the effect of treatment on whitebark pine mortality, specifically adult trees mortality, abundance, and regeneration? And also, we ask a question on what are the factors that affect individual tree mortality. Specifically, we ask to what extent do individual tree characteristics, site conditions, and treatment intensity affect individual tree mortality in the same period as the one for the first question, in this case, 15 years after treatment implementation. And a third question that focused on an assessment on the efficacy of the monitoring designs that we took on 2 fronts. The first one was to calculate what is the precision of estimation achieved for the 3 different variables that we were measuring, in this case, adult tree mortality, basal area change on competing conifers, and also regeneration. And another front, which is what is the replication needed to achieve different levels of precision of estimation for each one of these variables. So first, we wanted to know how good we're doing it, and how do we need to define or adjust the study design in order to achieve a specific margin of error. So for this end, probably a lot of us are familiar with Bob Keene's projects on restoring whitebark pine ecosystem, but it's always worthwhile just going over the details of it again. So my project is part of an ongoing long-term monitoring project called Restoring Whitebark Pine Communities that was designed to test the effect of selected thinning and prescribed burning as restoration treatments. And this study included a combination of 1 mechanical cuttings, prescribed burnings alone, and a combination of both, also including control units. Each one of these treatment units were measured before and up to 21 years after treatment. But if you may remember from my title, my assessment only goes up to 15 years after treatment. I'm going to go over that difference in just a few minutes. The original study was implemented at 5 sites in the northern Rocky Mountains of the United States. And these 5 sites are Smith Creek, Bear Overlook, Musgrove, Beaver Ridge, and Coyote Meadows. The majority of sites were in the later stages of succession, and prior to treatment, the overstory consisted of about 200 to 400-year-old whitebark pines in association with lodgepole pine stands with encroaching subalpine fir and some scattered large Engelmann spruce. In terms of the site selection criteria, from those 5 sites, I used all 5 of the original sites, but not all sites were used to answer every question. So to assess the ecological effect of treatments and the influence of treatment, site condition, and tree characteristic of individual tree mortality, which is questions 1 and 2, I only used data from Bear Overlook because it is the only site that was not affected by post-treatment wildfire. And to assess the efficacy of the monitoring design, in this case, question number 3, I used pre-treatment data collected from untreated control units from all 5 sites. So in this case, for this presentation, I'm only going to be using or predominantly using site number 1 per overlook. The treatment implemented across all these different sites could be classified in 3 main classes. The first one is prescribed burning. Hereafter, that I'm going to be referring to as RXF, was intended to mimic fire regimes present across the distribution of whitebark pine and also aim predominantly to reduce the abundance of competing conifers. The second type of treatment is nutcracker opening, which is a novel treatment type created by mechanically cutting trees of competing conifers within a circular area of varying size in order to enhance the natural regeneration and creating a more patchy distribution and subalpine forest. And the third type of treatment is slashing, which hereafter I'm going to refer to as MC, which were created by thinning old trees from competing species, leaving the slash to enhance fieldwork properties. From these 3 types of treatments, the ones that were implemented at Bear Overlook, so the site used for questions 1 and 2, only 1 and 3 took place or were implemented. In this case, only prescribed burning and slashing. The study design was focused using a nested plot approach in which the characteristics of the overstory were taken using a macro plot, and the characteristic of the understory were taken using a subplot. From the macro plot, measurements on all live species, all live tree species were taken, and those were separated between adult trees or mature trees and saplings. What made the distinction between them for mature trees was that all individuals that were above 12 centimeters of DVH were tagged and considered a mature tree, and saplings were all the individuals that were below 12 centimeters of DVH and above 1.37 meters in height. All the individuals that were below that range were considered regeneration, and those measurements were taken at the subplot. And the third variable that was extracted from the macro plot was the plot barn cover that was measured after the treatment implementation. From the subplot that we extracted all the characteristics on the understory, we only use, for the purpose of this presentation, the data on whitebark pine seedling density that were all the individuals below 1.37 meters of height. So now let's review the main results for these questions. I'm going to start first referring to whitebark pine adult tree mortality that makes responses from question 1 and question 2. In this case, for whitebark pine plot mortality, the data presented in these graphs on the left side panel is the mean plot mortality by the 15th year as percentages, and on the right side panel is the mean live mature tree densities as individuals per hectare. On the x-axis, you're going to see the 3 different types of experimental units referred to as CTRL, referred to as the control, RXF as burn only, and RXF plus MC, which is the combined treatment of prescribed burning and mechanical cutting on both panels. Also, the right side panel has a distinction on gray shaded bars for pre-treatment conditions of live mature trees and dark shaded bars for post-treatment conditions of live mature trees. Also, what is important, as I mentioned before, what I consider as mature trees in this case are all individuals above 12 centimeters DVH that were alive pre-treatment and follow all the way through the 15th years of measurements without accounting for additions throughout the 15 years. What I found is that plot mortality levels were not significantly different among treatments, and those treated units were also not significantly different from the control units, regardless of the initial conditions of live mature trees on either of those experimental units as well. So that is at the plot level. We were also interested to see what is the influence of individual tree characteristics, site conditions, and treatment intensity on adult tree mortality. For that end, we created a logistic regression in which we're interested on the factors that I just mentioned, using data on each one of the trees that were also above 12 centimeters DVH alive independently. This came out with a total of around 108 individuals across the 3 experimental units. And what we were trying to predict were the odds of mortality. So in other words, what were the factors influencing influencing positively or negatively the odds of mortality for each one of individual trees. The three characteristics that were considered for this approach were DVH, tree height, live crown base height, and crown scorch. We also consider as covariate two main type of variables. One is the stand conditions, which in this case is represented by the variable pre-treatment basal area, and also treatment intensity, which is represented by two variables. One, basal area removed, and second, area burned. As you can realize, the two variables that are related to treatment intensity don't have measurements for the control units. And we also wanted to account for interactions between one of the three characteristics and the two different types of variables related to treatment intensity. What we found is that none of the individual tree characteristics were significant predictors of whitebark pine mortality. Also, that basal area removed was significantly negatively related to mortality, and that there was significant interaction between basal area removed and DVH, but the interaction between DVH and area burned was not significant. What is important to extract from this is that these results indicate that larger trees were less susceptible to mortality with higher levels of basal area removal, potentially due to growth release that occur after thinning competing conifers, or at least that is what we came out as a potential explanation to. Although we did not specifically measure growth rate, there are previous studies that have found clear evidence linking thinning and growth release after thinning, most specifically Molly Retzlaff studies and also Bobkin studies in 2007 and 2018, if I'm not wrong. The next set of results has to do with whitebark pine and competing conifers abundance measures as difference in basal area change. The data presented here is going to be described as species specific in 4 different models, 1 for whitebark pine and 3 for the other competing conifers. I'm also going to keep using the same acronym for the experimental units as control, burn only, and combined treatment, and also using the same shaded legends for pre-treatment condition and post-treatment conditions for mean basal area. For whitebark pine, what I'm going to present on the left side panel is the mean change in live tree basal area by the 15 years in square meters per hectare. And on the right side panel, I'm going to be presenting the live tree basal area on square meters per hectare. What I did consider as trees for basal area in this case accounts for all the trees that were above 12 centimeters DVH and also all the saplings. So in this case, the results account for that extra group of individuals that were not accounted for in the mortality assessment for question 1. What I found here is that basal area decreased within all units, although there were no significant differences in the declines for whitebark pine. For the first competing species, in this case, subalpine fir, I found that basal area increased across all units, although these increases also were not significantly different among treated units, neither from those treated units and the control, regardless of the initial conditions. For the third competing species, Engelmann spruce, I found that basal area also increased in all units, and the magnitude of this increase varied significantly by type of treatment. Let's take a deeper look at this. Specifically, the burn-only unit, so this one that's in the center, was significantly different from the combined treatment, in this case, RXF and MC, but neither of them were significantly different from the initial conditions or the change experienced in the control unit, also regardless of the initial conditions of either of those experimental units. Some of the explanations that can explain those results is that in the burn-only unit, the higher increase in basal area is likely because the burning in this unit covered less area compared to the one with the combined treatment. And also because of this, more individuals survived in the burn-only unit. And also some of the seedlings that were present on the pre-treatment measurements grew enough as to be considered saplings or adult trees by the 15 years of measurement, unlike of what happened on the combined treatment unit. And for the third competing species, basal area decreased in the burn-only unit and increased in the combined treatment unit control, and where the difference among treatments were marginally significant. In this case, the marginally significance of the difference was defined because the p-value was of around 0.06. So it was worth for us to look deeper as to what made that difference among treatment units. So specifically in this case, the burn-only unit was significantly different from the combined treatment. However, neither of the treated units was different enough from the responses on change in basal area in the control unit. And some of the explanation as to why this happens are essentially quite similar to the ones experienced by Engelmann's screws. So in the burning-only unit, fire killed a large number of small trees, and there was a limited post-treatment regeneration. But in the combined effect unit, what happened is that sampling crews observed a substantial increment of regeneration after the implementation of the treatments, unlike the burn-only unit. All right, so let's wrap up some of the responses for this second question. So, are the treatments effective at reducing competing conifers abundance? What we found is that treatment did not reduce competing conifers abundance, and actually treatment may be benefit Engelmann spruce and lodgepole pine release and resource release. And a detail that is important to notice is that during the treatment implementation, the species that were considered the most for the thinning process are also the ones that experience the higher increments. And the levels of basal area, the current levels of base area for those two competing species are higher than the best condition of base area of whitebark pine. All right, so let's go now to the third part of the results. So, relative to whitebark pine seedling density or natural regeneration, the data that I'm going to present on the left side panel is the mean change in seedling density by the 15 years as individuals per hectare. And on the right side panel, I'm going to be presenting mean seedling density as individual per hectare as well. Similarly, as the previous plots and panels, I'm going to keep the same type of acronyms and same legends referring to the pre-treatment and post-treatment conditions. What I found is that over the 15-year period, the density of whitebark pine seedling decreased across all stands, and these changes were not significantly different among treatments, regardless of the initial conditions of either of those experimental units. So with these results, accounting also for the previous ones on basal area change and mortality, we had some initial thoughts on the results that focus on seedling specifically. That one is that even though the treatments were designed to create a catching habitat, these may not have been accounting for some limiting factors on the entire process describing the dispersal behavior of whitebark pine. Some of those could be the availability of nutcrackers or suitable microsites and conditions for seedling establishment. Some of those could be specifically canopy protection or neighboring vegetation and structure as the ones described by Melissa Jenkins' studies a few years ago. And a second thought that we had is that there was a considerate high rate of rust infection and beetle attack across sites, which may be impacting the structure of the stands and also the desirability of Clark's nutcracker to catch in those areas. However, from notes of the field crews that were taking data across those 15 years, they did saw frequent nutcracker catching during sampling across years. So that created some sort of confusion as to whether our results were actually describing what was happening in the field. And that raised questions on the ability of the sampling design to precisely estimate the specific variable, in this case, seedling density. So as a matter of wrap up in terms of regeneration, natural regeneration, we found that treatments implemented using our results described that these were not effective at enhancing natural regeneration, but that also tell us that maybe the sampling design may have some limitations to precisely estimate seedling density. So for that end, we come out with the last part of the study, which is making an assessment on the efficacy of the study design. As I presented in the research questions, we take the assessment of the efficacy in two main fronts. One is asking how precise is the design at estimating the population parameters. And the second one, which is using this design, what is the level of replication needed to achieve a given relative margin of error? Those two questions are going to be described by the left side panel and right side panel. The left side panel describes the relative margin of error as a percentage for each one of the variables that were included in the questions about ecological response. So adult tree mortality, basal area, and seedling density. And the right side panel is going to show the number of plots required for a given relative margin of error that is presented in the x-axis for each one of those variables presented before in the legend. So for the left side panel, in other words, how precise is this design at estimating the population parameters? We calculated the mean margin of error achieved for mortality, basal area, and seedling density, and the precision of estimation achieved varied across the response variables profusely. The main result says that the most precisely measured variable was basal area, which was calculated to have a relative margin of error of around 34%. And the other two variables, seedling density and tree mortality, were estimated to have a much higher error, in this case specific to 71% and 47% respectively. So that started to make more sense as to why we might not have been detecting an effect, and whether it was an issue with the design or maybe not having an effect actually of the treatment. So the right side panel that we use for asking what is the level of replication needed, we found that to achieve a 20% relative margin of error, which is 80% of the time having a probability of finding the population parameter represented by the line on the first tick mark of the relative margin of error axis, says that for basal area, we would need to have a minimum of 30 sampling plots instead of the 10s used using this design. For mortality, we would need to use 65 plots instead of the 10s implemented using this design. And for seedling density, instead of using the 10s implemented by the design, the required level of plots would be all the way up to 130. So this created some questions relative to what do we need to do now? Is it possible and feasible to increment that level of replication? Or is there something else that can be done in order to respond and make reliable ecological inference? So to wrap up this last question, how effective is the study design? We found that the higher error around the means reflects the difficulty of estimating this variable, given the high spatial and temporal variability of this ecosystem, and also emphasize that estimating highly variable with high turnover dynamics such as regeneration requires either increasing the level of replication a couple, not just a couple numbers, or having to push a change in the design and probably trying to use a different type of monitoring approach. So the main takeaways from these results is that our findings confirm that the complexity of designing effective monitoring programs is a reality, as well as making inference on ecological response to widely used treatments. So even though we are short about the impactful responses using a bucket design may not be easily implemented at every type of ecosystem, neither in the same way as we do across different type of setups. Specifically, these results highlight that some of the challenges presented on this project have also been presented in others widely implemented projects as a fire and fire surrogate study that used the same level of replication of 10 subsamples per site, and also had difficulty as estimating effective significant effects across different types of treatments relative to the controls for some of the study variables. Although we did not find significant effects on treatments to fulfill restoration objectives, it is unclear whether our results are driven by the lack of effects or due to limitations of the study design. And for this specific point, what we need to do, or what we recommend to do, is to integrate the inherent complexity of processes on the monitoring programs. And that means adjusting or defining a study design that correlates with the complexity of them. Consider including a much larger number of replicates when needed and when feasible, and to test what processes require a better sampling design to estimate the mean response. And most specifically, to plan for the future, even more now that we're in the light of studying the national strategy for the restoration of whitebark pine, we need to develop a large-scale, long-term monitoring network in which these pitfalls might be overcome as different working groups together. And before I close my presentation, I would like to express my deep gratitude to my friend and mentor, Dr. Karen Nelson, as well as my committee member, Dr. Robert King, for his patience and allowing me to use his data set on whitebark pine restoration. Also, Andrew Larson and Dr. David Patterson for their patience, guidance, and useful critiques for the creation of the manuscript and the development and implementation of the projects. And I would also like to extend my thanks to all the sponsors that made this project possible, including the Society of Ecological Restoration and different sources of funding from the College of Forestry and Conservation at UM. And with all this, I would like to open the room for questions and comments to all the attendants. Thank you very much.
Thank you, Enzo. Excellent talk. If you all want to put questions in the chat, you're welcome to do that and I can read them. We can also enable, if you raise your hand, we can also enable you to speak directly.
Am I on, Laurel?
Yeah.
That was thanks, Enzo. That was really interesting and great discussion on the sampling. One thing that caught my attention was the aggressive response of lodgepole and the spruce after those treatments. Probably not a surprise, but thinking of management treatments, I guess I would like to see future studies on if we keep treating or repeated treatment of keeping those spruce and lodgepole competition out, would we have a greater success in recruiting whitebark, or if those young trees are essentially competing with each other and whitebark is losing as a young seedling. So that was probably a pretty clear message to me in how those trees are regenerating right after or responding right after treatment. So thank you very much.
Thank you for your comment. That's actually a quite accurate, correct comment. We discussed that with my committee after my defense as to what would be the ideal strategy in terms of compensate for this coming back trend of for Engelmann spruce and also for subalpine fir and in some places for lodgepole pine. Having a multiple treatment across the years would definitely be best practices, but we also think of determining or implementing this at different levels to see which level of implementation would work best for the same reason of like not having to use too many funds, even more when we're planning to do multiple treatments across years. So maybe this would be enough if we implement those treatments just 3 times every 5 or every 4 to 5 years. But what we need to know also is like how intensively to do it in order to keep the structure conditions, at a level that in natural regeneration can be enhanced, and also preventing damage to existing mature trees and saplings of whitebark pine.
Oh, good point. Yeah, I think my experience is in the management and treatment prescriptions. And so much of dealing with competing vegetation, you have to, it's not a one-time treatment, but the opportunity to repeat treatments is obviously a financial issue. So that's a good point, that what is the intensity of those repeated treatments if you need them to have the best effect. So thanks.
And also one last point about that, like what type of treatments are feasible to re-implement, because
right.
We all know like how difficult it is to get a permission to implement a prescribed burning. So maybe mechanical cutting could be feasible as re-implementation, but prescribed burning not as easy.
Right, and you probably
location.
Yeah, and you have a little less predictability with thinning as far as damage to your residuals and air quality and all that kind of stuff. So I think those are good questions to keep monitoring and implementing test treatments for. Thanks.
All right, we have quite a few questions in the chat now. I see Kathy Roche says, did you target non-whitebark pine in the burning?
Wait, I'm looking for, did you target non-whitebark pine in the burning? The only thing that, so for the sites that were burned, what happened is that there was some slushing, but the only species that were targeting the cutting and in the sites that were combined, that had a combined treatments, were competing species, specifically Engelmann spruce and subalpine fern, but not so much lodgepole pine. So I don't know if that would respond to the question, but I'm not sure whether I'm capturing directly.
Yeah, I think you answered it. Kathy, did you want to follow up at all? Okay, I will keep an eye out. Let's see. So Aaron Elliott asks, how could studies potentially be better designed in the future to accurately capture seeding density? So I'm wondering if this has to do with like, yeah, I was wondering if they mean seedling density or seeding density, like seed rain.
Well,
Oh, okay, it is seedling.
To make a proper population estimation, we need to make sure that the way that we're monitoring seedling density accounts for its level of turnover. So measuring a plot every year is not necessarily going to measure the same seedlings. Maybe the first year is going to have all the seedlings. The second year, I might have new seedlings. Some of the seedlings present in the first years may not longer be there. So it's not as stable as to measure a living tree. So some ways of there are some designs that account for the level of sparseness of seedlings, even more for systems that have such a complex seedling distribution of whitebark pine that we can discuss later. So if you can send me an email, we can go over the specifics of that. But there are ways to compensate the complexity of the distribution of seedlings, as well as the temporal variability of their existence.
Fantastic. All right, so Colleen asks, are the competing species also susceptible to beetles and blister rust?
Good question. From my experience, I cannot answer that question effectively, but I can refer that questions to one of my collaborators and have a much effective response to it.
Listen.
Can you quick patch on me?
Sure.
Yeah, my understanding is that blister rust only impacts 5-needle white pines, but mountain pine beetle, perhaps that targets lodgepole. I'm actually not sure. I would need to double check that, but okay, so let's see. There's a comment from Mojda. Thank you for your presentation. I was wondering why you decided not to look at the effects of mechanical cutting alone. I'm thinking that fire may induce seed germination of competing pines. Thank you.
All right, so one of the main limitations is as to which were the treatments that were implemented, where the size also of the sites was the permits given by the district managers of the Forest Service. So even though originally all these units were planned at much bigger sizes, the areas that were actually permitted to implement them were not sufficient or big enough as to implement every single one of the treatments. It would have been great to have like a full block design in which each one of the treatments were implemented, but that was not the case for every site, neither every experimental unit. So that was implemented at other sites, but those sites were affected by post-treatment wildfires. So yeah, it was part of the original plan, but it was not applied in that sense at every single site.
Thank you. Okay, let's see. Chris Clark, he says, I'm wondering if there is a treatment monitoring protocol that is currently most recommended, and if there is a process of site stratification that has been developed and could be used range-wide.
That's an interesting question, and the best thing I can answer is that there are no silver bullets for monitoring designs for neither ecosystem nor every project. Best practices would be to have a sound understanding of the process that you're trying to study before implementing a monitoring design, and that making sure to make a pre-measurement in order to establish the power of your sampling design, and whether the sampling design that you want to implement at a bigger scale could respond or could be affected at determining the effect of your treatment or determining the response of your variable. So there is not a single one that works for everything, but that also tells you that you need to make a test before making a bigger implementation.
Awesome. What about for Whitebark specifically? I'm wondering if that's what he means.
For Whitebark specific, not to my knowledge, and actually that is part of my, that is going to be part of my PhD program in order to test which monitoring designs are most effective at capturing certain variables. Of course, there are variables that work at much higher temporal scales at PhD programmed period, but
Sure.
we'll try to do the best we can with simulation processes and also in-field measurements.
Excellent. I'm looking forward to seeing that. All right, let's see. Were sites on both north and south-facing slopes, so any stratification by aspect? I'm wondering if, this is Stephen also, sorry. I'm wondering if trees as facilitators of seedlings, the nurse plant effect versus competitors might depend on microclimate or aspect of the site, and might be muddling an overall effect. I'm wondering if he's asking because of Whitebark's role at treeline potentially as a nurse plant.
Yeah, well, these the population in which the sites were located are not tree-line populations, but we did account for all those factors, and those factors are not as, we don't think are as important as the predominance of mountain pine beetle attack and also blister rust infection. So we do believe that that the health conditions of the stands in which these treatments were implemented are already at a point in which the management actions cannot compensate for the degradation of it, and for that same issue may not be a suitable place for nutcrackers populations to keep catching and hazing natural regeneration. However, our results don't necessarily match with what we think. So that is where we need to define whether it is the monitoring program or actually the lack of an effect of the treatment. But all those factors may take into account, not necessarily the site conditions, like the aspect or like the aspect predominantly, as you ask.
Awesome, thank you. Well reasoned. Also, I'm sorry, that was Stephanie Jelinek. I had my cursor over the question, and so it hit her name, but okay. Ethan Ellsworth wants to know if you've published your work yet for this.
So there are two sources that have already been published, not on peer review articles. One of them is my master thesis on the dataset, and the other one is an article on the proceedings of the last High Five conference. And the actual peer review publication, it's on this last stage of editing, and it's probably going to be sent to the Restoration Ecology Journal in the coming weeks. So if we're lucky, we're going to have our publication ready and available in the coming months.
Excellent. Nice work. I just posted a link to the High Five proceedings for that in the chat.
Thank you.
Yeah, thank you. All right. See, how large were the treated stands on average? This is Patrick Bennett.
How large? I don't have that on top of my mind, but if you can send me their email, I can just send all the information in terms of like site specifics right after the talk.
Thanks, Enzo. Patrick, if you hear that, DM Enzo or me. All right. John Van Gundy has a comment. My experience with private thinning projects, if you burn or thin in areas with lodgepole, it creates an opportunity for lodgepole to become the dominant species. Serially thinning burning is very expensive over the long term, but effective. So maybe it's just repeated treatments. That was a comment. And then actually, I had a question for you, if you don't mind.
Can I answer something to you, John, before that?
Yeah. Sorry.
All right. I would totally agree with what John said, but from our responses, something that we got really surprised at is that we were expecting to see a high increase or like a peak increase with lodgepole pine, but what we saw is that in areas in which there were not as many propagules in the seed bank and where lodgepole pine were killed during the burning process, we did not experience any growth, and actually the increase of basal area was marginal, but the area in which some of the mature lodgepole pine remain after treatment implementation, we did experience a profuse regeneration by the 15 years. So I think it's a matter of like having a propagule source, but also a seed, like a consistent seed bank or available seed bank.
That makes sense. Okay. Do you think that seed dispersal could be a factor influencing the efficacy of these treatments? So like nutcracker caching and.
Definitely. Well, as I mentioned in the beginning, this type of management interventions are only looking at managing the structure of the stems, but the structure of the stem is one of the multiple factors that affect whitebark pine dispersal. And we need to remember that the main source of dispersal of whitebark is nutcracker. So if we're not accounting of how stem structure affect nutcracker populations, we wouldn't have a fair understanding of how these practices can enhance natural regeneration or not. I do believe that without nutcrackers, there are no whitebark pine regeneration. So definitely, yes, just the way that we assess this project cannot answer those questions because it was only focusing on the structure characteristics.
That makes sense. Do you think that you might look into that in the future, or?
That would be amazing. However, there are many other prolific researchers and students such as Vlad Kovalenko that's also studying that. And
yeah,
I'm excited to see their response, their results on their own project. So yeah, definitely. We're a big network, so everybody can make their own contribution in every single one of those aspects. So yes.
Excellent. Actually, Vlad's talk is coming up in a couple months, I believe, on April 18th, if that's of interest. I'm looking forward to it. Thank you. Any other questions for Enzo? Aha, we have another. Jason Glenn asked, do you think a larger plot for seedlings could result in a lower margin of error? Or is there so much variability in seedling distribution that it wouldn't matter?
That's a rather interesting question because if it were in whitebark, I would go with a yes, definitely. But in this case, since whitebark pine dispersal dynamics are not defined by the deciduous cones, or that the seeds don't disperse by themselves, and they actually use the corvid for its dispersal. Using bigger plots might not necessarily be the answer. In this case, a better approach would be having a non-systematic and also a non-systematic approach in the distribution of the plots. Increasing the plot size is definitely something that is going to increase the effectiveness of capturing the population parameter, but not just the plot size. Also, the way that the plots are distributed across the study sites is also super important. There are some strategies that don't account just for a systematic approach or just a random one that can help you compensate for those issues. So in this case, there might be factors that may be clustering where Clark nutcrackers desires to cache. That might not be just like random or evenly distributed across the study site. So to answer your question, increasing the plot size may help, but it's not the final response. It has to be coupled with plot size, and also how do you distribute the plots across the study area.
Good answer. There's one more question from Robin. Were the lodgepole in the study areas serotinous or not? Because that can affect reproduction.
That's a good point. I don't have information about that specific factor, but I could ask one of my collaborators to answer it after the talk.
Sounds good. And I think there's a comment from Kristen Williams. I think I'll let you read that directly. If we have a little bit, we have about 4 minutes here before the end. I know there was a request. There was a request from Julie Shamhart to recap the Whitebark Pine Ecosystem Foundation 2022 accomplishments.
I can definitely answer this after the call. I'll just like copy it, and if you can send me their contact, I'll do it right away.
Awesome. Yeah. Folks, definitely put your email in the chat, DM one of us so that you can follow up. Okay. I think there's not quite enough time for the end of year achievements, but yeah. Any other questions, or shall we call it a day? All right, excellent. Thank you so much, Enzo. We'll leave this up for a minute so that you can grab emails. Yeah, thank you so much for the presentation. It's really exciting research.
Thank you.
And I'm looking forward to seeing what you do with your PhD.